So thanks to Michael and Amir for actually inviting me to coming over here. And this is my first visit to Israel. Things have been very nice so far. So thanks everybody. I hope you can hear me in the end, right? My generally voice is big, but I just want to make sure. Okay, so today I'm going to talk about blockchain privacy, and I'll try to focus on some networking aspect, but eventually there will be crypto-related things which I'll try to cover. And what I look at is not only I'm going to talk about how are we trying to solve or how are we solving this problem now, but my focus will be also to show you nice things that, hey, these are the interesting things that we should do. And my hope is that maybe in the end, some of these also lead to some interesting collaborations. So I'll start briefly giving my take on how I look at this whole blockchain systems. So if I started to look from maybe early days while I was still a high school student or maybe undergrad, undergrad sounds reasonable, there was a shift from the, when I look at the communication as we were performing, from local to global. In the sense that we were no longer relying on only our social circles, which is next to us, but we had things such as Facebooks and Orkut and you name it. When we want to take a taxi in some new country, I don't need to actually know things over there or find out the taxi company there. Hopefully my app, Uber or Lyft, whatever you like it, can help me to actually travel in that country. If I want to buy something, I don't need to go to the local store or know somewhere how to find it. I'll just search on this Amazon or eBay place and find all those things. So we started to see this shift from the local to global systems. But they had one similarity to this local system, which was they were centralized. There is still one company, one governing body who was making all these decisions. Especially in case of the payment systems, mostly because of, I'll say, subprime issue, the big subprime issue that happened in all over the world in 2008 or 2008, 2009, people started to think about decentralized solution. Can we come up with a decentralized solution so that there is no single party who makes the decision and others has to just obey it or don't use the system? And in some cases, you just don't have an option. You have to just obey it. And that gave rise to the whole system of It started with Bitcoin as the first thing, and for several years it was only that, with most people suspicious that, hey, how is this going to survive, or is this going to survive? There are just so many issues in this system. But as we are seeing now, all these systems have been becoming bigger and bigger. There are newer systems coming every day in in this environment, and we are seeing a huge growth. Some of them still went from decentralized to centralized, but still the overall underlying theme of decentralization remains. Okay. In fact, the situation is very interesting now that in industry, almost all big companies, the CTO will talk to their managers and their engineers, say that, hey, where can we use blockchain? And several times, in fact, people are trying to do blockchain for everything. I'm certainly going to say that several of those application scenarios, when I hear from these people, I just feel like, really, do you need blockchain? But there are still some scenarios where this is helpful and useful, and so probably we are going to see all of these some of these unnecessary things die down, and we'll find some really core situations where blockchains will get used. So indeed, in that respect, although we see blockchain for everything, eventually we'll have scenario where these decentralized solutions will get used for some very particular important use cases. So cryptocurrencies or some of the applications may or may not survive because some government may regulate them in different ways, and then people may find that, hey, this is too expensive. Already I'm spending the Bitcoin fees are large enough that maybe I'll just use my credit card and stuff like that. That may happen, but the concept of distributed ledger is here to stay. People say that, yeah, we want this concept in different applications and in different scenarios. So this is just like quite old slide, I'll say that, but this just shows that until 2014 or something, there was hardly any company who was interested in this space. But from 2015 onwards, and we just started to see huge interest in this field in the industry, coming from the bigger companies to the startups and all this field. In fact, this is also not the complete space, but this also shows that there are businesses and startups and big companies working at different layers, starting with really infrastructure and the base protocols where they try to work on the key core technology for the blockchain, to the defining interesting middlewares and different applications such as the trading platforms or applications to supply chain, you name it. There are people are working, there are companies and startups and groups working on several of these aspects. So in this talk, what I'll try to focus on is that I'll look at these things as three things, like the good, bad, and the ugly. That's how I was able to differentiate themselves. I'll start and spend some time on basics of Bitcoin basics or blockchain basics, because I'm hoping that not everybody here has that knowledge. So we'll start with some very basics of Bitcoin. In fact, the way we are going to develop is we are going to build a coin today by ourselves here. Okay, then I'll talk about a little bit of evolution and the applications of this space. Then I'll move on to the bad part, which I want to focus on, which will be the privacy and linkability attacks, which are inherent to such open ledger systems, and the de-anonymization that happens. And finally, I'll spend time on ugly, which is basically the reason I gave the name ugly over there is because there are solutions which are present over there, but they don't solve the problem in the perfect sense, that there are just lots of too many combinations and too much glitch which is present in this whole scenario. And we'll try to look into some of those interesting aspects here. Okay, so the first thing, the good part, right? So what we want to look into is the first application that come for this blockchain was a cryptocurrency. And in the cryptocurrency, the currency part is what we'll start with to begin. Okay, so we know that the currency, when we talk about currency, we think of money. And the way we use our money today, the key thing associated with that is store of value, which means that people can save it in our wallets, in the like safes and everywhere, and use it later to purchase some things over the time. The important thing that is associated with that is that its value is not going to just degrade quickly. You will always have a value associated with it, and we can use that as a base of the price. We know how to differentiate. We know that the laptop costs more in terms of money as compared to this particular the clicker. And so we can differentiate them. We can actually compare the price in this currency aspects because it provides us a nice unit of account. Okay. And once we have these two things in place, now we can use this as a medium of exchange so that you can buy or trade things with others based on this currency unit or this currency itself, when it is form of the physical form where they are actually the notes, or it can be checks or some other form. Okay. So that's how we know the money or the currency. But I like to actually take an example, which some of you might have already seen in some blockchain talks. But it's a very nice example to show that what kind of money that we really need. And that is an example from which is known as the stone money from this Yap Island. Okay, so this Yap Island is a Pacific island where they have a very interesting form of currency that they use for several of the transactions. So they have not on that island, but an island not so far from there. They can actually there's a query, and they can actually make these circular discs with a hole in between, and they use each of these discs as a money unit. And the idea they see is that they basically mine out there in that island, in that other place, and then they put them in the ships and bring to the island, and they place it at somewhere. Okay, and the idea is that they try to keep an oral history that, okay, now this particular stone at this location belongs to this person. And maybe eventually you will decide that no, we'll have some mans and we'll use them to actually bring them to close to my house or something like that. But the idea is that everyone will just remember, oh, that stone over there belongs to now this person. And when this person actually gives it to somebody else in return of some good, now you'll see that, oh, now it's no longer belong to him, but it belongs to this other person. And that's what they use for the money system in general, and you can find lots of such stones over there. There is also a very interesting story associated with it. I mean, even more interesting story, I must say, where that at times they try to query some of these, and that ship which was bringing those to the island capsized, and all of those stones, they fall in Pacific somewhere. Okay, but the guy who was actually taking care of that survived and returned and said that look, I was there for these many days and I actually made so many of those, but see, I can't bring them here, they are somewhere in Pacific. And they decided, okay, that's fine, we can still count them, and we'll use that, assume that those stones which are lying somewhere there in Pacific belongs to now this person. Okay, so what is, I mean, it's an interesting story on its own, but what it shows is that when we look at the money, I guess the key thing that we have to look into the in this case oral history, or I'll use the word history. So if we can do good bookkeeping, maybe that is sufficient to just have the effect of money. In fact, I'm going to claim that it's beyond that. I mean, maybe money is just very small after bookkeeping is sufficient to do much more complex financial transactions than the money. But for our purpose, we'll just stick to the money aspect of it, or the things. So that's what we'll say, that the history is sufficient to keep track of all the transactions and to generate a money system. And that's what I'll say in general, we can say is sufficient to build the whole currency system. So with that example in our head, we'll start now preparing our own digital currency. I thought that will be a good approach to understand basics of Bitcoin. Okay, so for that to happen, we have to understand two simple concepts from cryptography. We are not going to look at any mathematics, but we just understand them at the conceptual level. And the first is very simple, which is basically we call as digital signature, which we can look at as a digital counterpart of our standard signature systems. Okay, so what happens in digital signature, basically we assume that we have Alice over here. Okay, what she is going to do is she wants to sign a message, as if like we sign with the paper. But digital signature, I think, is maybe more powerful than our standard signatures, but it's fine, I guess. We can take this message. What she does is she hashes this, basically compress that to a particular, bring that to a size where you can sign it, and basically applies an algorithm, which is a signing algorithm, which takes as a signing key, a private key that only known to the Alice in computation, and use this information to generate a signature. And now the signature can be sent to anybody or can be made public, such that anybody, in our particular case Bob, who knows a respective public key or verification key associated with the signing key, which can be known to everybody, once they know this key, they can take this message and signature pair with this verification key, with this public key, and perform the verification. Okay, that's it. It's similar to that I signed something and you can see that afterwards. So that's a very basic concept. The next thing that I want is hash function. Okay, hash function is also something very very basic that we all know, but what we particularly want is cryptographic hash function. So what hash function is typically the lossy function, where we take a bigger input and we hash that to some small value. What we want, particular properties we want from hash function, is it should look random. That means for any input, every bit becoming 0 or 1 is uniformly random. It's very informal definition. My apologies for if there are some theoreticians here, but I just wanted to give the feeling that what we need to have is that it should be a random value. What two properties that we want typically with the hash function, the way we use is that, let's say we pick a value in the digest space or the output space. It should be difficult to find out the two pre-image for that. Let's say even if one pre-image you can find by using this value x and going there, but it should be difficult to find out x prime, so that hash of x prime is equal to hash of x. Okay, that's we typically use the second pre-image, but in fact we want even higher property, that it should be very difficult in general for anybody to find out a pair x and x prime such that they both hash to the same value. Okay, that we call typically the collision resistance property. So it should be difficult to find collisions, and the output should look uniformly at random. That's the two key properties that we want to build our thing. And that's it. These two things, very basic things, are sufficient to start building a cryptocurrency that we like to bring. And we'll try to build that through some things which eventually you'll realize, or you'll immediately realize that this is stupid or this does not achieve the property, but we'll keep on adding newer components to it to eventually build what we want to build. Okay, by the way, I didn't mention, but feel free to stop me at any point of time and ask questions if there's something that comes to your mind. Okay, I'll be very happy if this is more interactive than just in the end we have questions. Okay. Yes, so the first step that we like to do is that assign intent of the letter. So what I'm going to do here, that we are again going to use just our digital signature concept that we studied. And here what Alice does is that she has a public key, and let's say Bob knows that public key, or maybe somehow it's known that this public key belongs to Alice. She's going to only make a signature saying that I give you one P coin. I'm using the word P coin because I'm from Purdue, so that's why I'm using that. Actually, I used to use boiler coin, but I don't think people will get joke over here. So that's the reason I didn't use that. But yeah, so let's say Alice giving Bob one P coin, and so basically it's a message that's taken by Alice, and she signs this message and give that to Bob. Okay, it shows there is an intent from Alice's part to give this particular currency to Bob. Okay, so interesting feature that this thing has, that it establishes the intent on Alice's part that she actually want to give the money, and it has some form of limited protection of forgery that some other Carol or some other Dave can't do that on Alice's behalf. It's only the Alice who has to do this.
Who links Alice to her public key?
Sorry?
Who links Alice to her?
So let's say for now we are going to assume that we have done somehow it knows that everybody knows Alice's public key, but we are going to even throw away that requirement. In fact, that will be our rather one of the final steps to do it. But for now, assume that everybody knows Alice's public key. Okay? Yeah. Good question. Yeah. So, but the question is that, is it really money over here? I mean, it's very easy for Alice to just keep on signing such statements, right? There's no value creation, or there is nothing that she has to back it with, or anything like that. She can just say, oh yeah, take the new one, take the new one. Or maybe she can just replay the same message, right? We haven't done anything yet to stop even that basic simple things. So the way we can do that is maybe we can try to make this a unique P coin, right? So we'll try to use serial numbers. Okay, so what we'll say that now Alice is giving Bob one, oh, I didn't convert this one. Okay, P coin, assume that's P coin with the serial number 235. I went through everything, but here's one which I forgot. Okay, and the key thing that we want, if we want to add such a number, is that we have to have a trusted source of such serial numbers. Right? Because maybe we want to use the same serial number source for all different people. Okay, so why don't we then try to do something like that? Let's say we have a trusted source. Let's say I'm using Purdue Federal here, that there is one source who generates such serial numbers. And what we can do is that we can use this source also to check that is this real correct owner of that particular serial number or not. So the way this is going to happen is that in this case, let's say when Alice actually has some real money, let's say dollars, she goes to Purdue Federal, put them in the Purdue Federal account, and Purdue says that, okay, this is the serial number that I'm giving you for this 1 unit of money. Okay, she takes this number and now she wants to pay to Bob, and she provides such a signed statement and let it goes to the Bob. Now Bob, once it sees such a statement, the first thing it's going to say or query this Purdue Federal that, hey, is Alice true owner of this 235 currently? And this guy is just going to have a table of like who owes which serial number, kind of a table, and then they're going to say yes or no. And once they hear yes, then Bob know that, oh, this is fine, now I'm ready to accept, I know this is coming from Alice, and I'm ready to accept this particular information. Okay, so the idea is that this particular verification has to do two things: that it has to check that money is actually present in the database, and that it hasn't been already spent by Alice. And the best thing is maybe you add a flag there, or you just remove the entry from the Alice once Alice spent this money by sending such a signed statement to somebody. Okay. And obviously, for the final settlement, the Bob has to send this statement or this signed statement to the Purdue Federal, so that Purdue Federal know that Bob is not cheating and just trying to get money from somebody. So that's the advantage of having that signature over there. Okay. So once we have these things in place, it seems like we have at least a working protocol, but there are huge challenges. In fact, I'll say that the first generation of cryptocurrencies, as we call them today, or the e-cash from 90s, was such a central system. I mean, they were doing more interesting things by adding privacy to this whole setup, which we are not considering so far. But the previous setup was something like they were having one server who actually keep tracks of such things. And the question then we had is that what we want to solve is that, hey, instead of having such one trusted source of system, can we make this whole system as a distributed systems and use that to actually perform all this verification, okay? And that's what our aim is, which I'll take now. Third step is that rather than having one source or one trusted source for all the currency, can the whole system work as a collective bank, or as a collective source of the verification and checking that transaction happen is what we go for. So basically what we hope is that everyone, or at least many of them, keep track of P coins, keep a complete record of what all transaction happen for all the P coins, such that now whenever a transaction happen, whenever a party provides a signed statement with the serial number and try to transfer some money from that person to other person, the receiver can basically take such a transaction, use this ledger or the collective system that is present there and try to find out, is it already spent, or is that money already spent, or it's money that I can actually get as a valid money, and get yes and no kind of answer, and then basically approve the transaction and move on, okay? So that's what we can look at, that's what we want to achieve. The question is, although it's still a cloud, and we want to convert that cloud to something tangible system. And as it turns out, because we are talking about the people, which is a system and of people and collective system, we are a typically network which we like to start is a peer-to-peer system. So we'll hope that there are already existing records, which records are typically known as blockchains. Why we call it blockchain will become clear slightly later, but let's assume that this is it's a record system, and you will keep on collecting the newer and newer records or newer messages that they are coming, and your idea is that you're going to basically flood this information into the network using the typical diffusion algorithm, so that everybody knows the newer system, newer things that we want to send. You combine them together and try to create the next thing that you can add to the system, okay? Seems, I mean, although I said as if like this looks natural, but it's a very, it is a generally difficult process where things can go wrong in very different manner, because now we have a whole distributed system. And the key example that we can look here is that what if we have Alice here and she's trying to spend the same coin to both Bob and Charlie, okay? So in one case that I'm giving the serial number 235 to Bob, and the second thing she's saying I'm giving that to Charlie. Okay, and we have such a system which is present there, and what should happen in such a network scenario is that only one of them should get accepted. The second one should be thrown out or not get accepted to the system, because if we accept both of them, then basically she got one coin and she was able to double spend that or spend it twice, which we want to avoid. Okay, so the idea is that once there are enough people who are broadcasting message, they'll realize that there are two transactions and they have to agree on only one of them, and that's a double spending problem that we have to solve. Okay, and the way we solve double spending problem, it's because it's very closely related to, I'll say, the whole consensus system. So that you have to agree, the whole network has to agree on, have a consensus whether to accept the transaction to Bob or whether to accept the transaction to Charlie. All right, and they have to agree on that. But the challenge is that how we run a consensus system in a completely distributed network where anybody can join anywhere at any given point of time. Okay. Because maybe if you allow anybody to join and basically use the standard consensus, as probably you might have seen in your distributed systems course, once there is the number of majority becomes dishonest or belonging to one person, they can just basically rewrite the whole history or do something like that. So that's why basically it's possible for any Alice to create lots of stock identities, lots of civil identities, and they may try to cheat the system by having majority of votes from their side. Okay, so what we can do maybe is that the key idea will be to actually make this process artificially more difficult, such that you may try to add more identity, that's fine, but as long as you do not have or you do not owe majority of the computing power in the system, you cannot trick the system and reverse the log, or as long as there is an honest majority, things will behave as they should be. Okay, and the idea is that once those parties will have to perform this computation, and the computation that we perform, we typically call that as a very particular puzzle that we can use, or that's used in Bitcoin, is that which uses the hash functions now here. And the idea here is that you are going to take the transactions that you want to add to the current system in the next step, and your aim is to find out a random nonce, a random value, so that when you hash both the nonce value and the set of transactions together, you get a output of a particular kind. Okay, for simplicity, it should what they use in Bitcoin is that you need to get an output whose hash begin with a long run of zeros, and assuming that the hash outputs are random like. This will be a brute force system, so that you have to keep on performing lots of computation, such that then you get such a long runs of zeros. Okay, I'm just here showing example such that I'm just taking message as the hello world, that's my message, and I'm keep on trying value 0 and so on, and I have to do lots of such perform these hash computations in a brute force manner to reach a value, so that then eventually I know that I'm getting the 4 zeros to begin with. Okay, so that's an example of a computational puzzle. Idea is that because this computation cannot be made faster, you may try to make things faster by adding more computing power, but as long as half of the computing power or more than half of the computing power remains honest, you are doing good. Okay, so with that, then what we have seen already is that we will have such currently not the transactions which are created but not yet added to the system. You'll send them to the miners or the people who are doing these computations, and then they are going to take those computations and try to create new blocks such that they satisfy this requirement of having several zeros to begin with, and send them to the blockchain, and so on the process continues. And those once they create such block, they will try to join this chain, and things will continue. Okay, so obviously it's still possible that in the network simultaneously there are two people who creates the block nearly at the same time, and they both try to say that no, let me add my block or my computation to the system. I didn't talk about that in detail, but the idea is that we also add a link, a pointer to the previous block into the current block, just so that we form the chain, so that people can't even make changes in the past system. But yeah, coming back to the problem that I want to talk about is that it's possible that we have multiple blocks which get mined simultaneously, which are legitimate and which point to the correct block. And the choice we make between them is basically is the longest chain is always the one which will win over the long period. So when a new person comes, he'll try to find out something from there onwards rather than going for something in block. Okay, but I'm not going to the detail. There's a lot of the interesting things that can happen in this space, but I'm not going to detail because I know the next two talks will talk much more about this process in detail, and I see Jonathan here who will be talking in detail about this whole mining process in the afternoon or the evening, the way you call it here. So the idea is that the longest chain is what we use here, and we'll move on from there. And in fact, people have already put efforts to actually formalize these properties, that what we want to actually achieve in such a system in terms of the two properties, which is the common prefix and the chain quality, and they are able to prove that as long as there is an honest majority, we achieve these two properties. Okay, but again, I think it will. We are going to discuss that in detail later, so I'll probably skip this part and focus more on the topics that I want to cover with the privacy. Because I guess we are going to talk a bit more about that in the coming things. So now the final thing to add is that what we have worked on this Pcoin, I guess you all know by now it's very, very close to Bitcoin, and it is close to Bitcoin, except for one change, which I like to add here, is that we don't need to have identities, right? What's the use of having this Alice and Bob as identity? In fact, we can use these public and private key pairs as our temporary or pseudo identities. Okay, and that's what happened in Bitcoin. So Bitcoin, my identity or my address will be basically hash of my public key or hash of my verification key. Okay, and when somebody wants to send money to me, I just need to tell them, hey, this is the hash of my public key, send money to this hash value. So that when I want to transfer to somebody else, I can basically just use this hash value and then use the respective public key associated with the use the respective private key associated with the public key that I got and transfer that money to others. So as I'm showing over here, what I have input addresses, which is just my, let's say Alice. Alice has currently 70.345 Bitcoin, quite rich. And she's going to, let's say, transfer 1 Bitcoin to this Bob. That's the address B prime, okay? And rest of the money goes back to her return address. It can be same, but typically it's a different new address. You don't need to use just one address. You can keep on adding more addresses to the system. And you take this as a transaction, and this is signed by a signature which is provided by Alice. This is the sigma A, which is a signature created by Alice. And you take this transaction and you send that to the peer-to-peer system of Bitcoin so that it gets flooded throughout the network. And your hope is that eventually it will get mined and added to such series of blockchain. Okay, so these are the basic things that I wanted to cover. Any questions so far, or things are good? Good. All right. So as I already mentioned.
I have one clarification. In the Bitcoin protocol,
yeah.
do you use your own balance for the address, or you just use the specific transactions of that address?
So we use, typically when we talk about, we can add the multiple links to things here. And based on that, you can basically, you have all the links for the previous transaction, and you can it's not based on the address, it's based on the link to the previous transaction.
So how does the Bitcoin cookie check that no other transaction happened after that transaction?
So yeah, that's where interesting thing happens, because most of the miners, not only they keep the blockchains, but at the same time they keep the whole track of, for each addresses, what is the current unspent amount that they have to keep for the faster processing.
Yeah, otherwise they have to just search entire
every time again. So they, rather than that, they keep a log of all the things that, hey, these are the things which are present and for this
address, these are the transactions.
And then they can do that. Otherwise it can be, given the current size of blockchain, it can be very
what's the current size, do you know?
Yeah, we'll look into that. I think it's more, I think it's around 150 gigabytes, so it's a huge thing. Yeah, so the reason why it got, people got interested in such a system is because it's arguably fast. I mean, there are payment protocols which are slower than that. It used to be cheap. I'm not going to claim that it's cheap any longer, given the Bitcoin price, but that's just one more thing worked. There is no central authority, so people say that, hey, I can become part of the decision process, and there is no central authority which is placed in that. And there was also the feeling that people have that, hey, this is private, my identity is never present in such a system, so I have a good privacy. And that was also something which several people liked, and they found that to be interesting. Okay, and that's the reason people got interested, and then people also developed different versions of same systems and different versions of the Bitcoin, and there are lots of, I guess now, I mean, this is very old, maybe now we have easily more than 100, 200 different coins which are present. Not all of them are prominent, but at least several of them are still doing very well. Okay, but as I already mentioned, people have also gone beyond just the payment scenario. In fact, in payment scenario also, people looked into the systems such as Ethereum, where idea is that not only it will be a system for transaction money, but also it will be a universal computer, something like that. We are going to look into the IOU credit network. That will be my talk on Tuesday, where we look into this particular example of the credit networks and how they're different from the standard cryptocurrency that we're looking into. And basically people are looking into developing what is known as Internet of Value, so that all these systems can interact with together and stuff like that. There are companies which are using this for the identity management, And there are also people who are looking into the applications of that in supply chain, like tracking diamonds, goods, food, whatever you name it. There are lots of interesting companies that are working in this space as well. So again, very briefly touching upon the other two prominent examples on this blockchain scenario, other than just the plain Bitcoin, I guess the example that I have to take is Ethereum. The Ethereum the Bitcoin had a small scripting system so that you can verify this transaction, and you can do some things beyond that. Okay, and we are going to see the example. But they still try to keep that as a stack-based programming, and you are very restricted in terms of the things that you can do. Basically, there are no loops which are possible. But instead, then people realize that no, we want Turing completeness in terms of the things that we can perform on such a system, on all these operations, so that I want to do everything that possible. I can basically write a program with all possibilities, and I should be able to employ that. And that's where the Ethereum comes in picture, where the idea is that you can create contracts or programs which are basically Turing complete programs. You can write anything that you want, and the program will reside on such a system, okay? And anybody, it will have its own memory, it will have its own code, it will have its own currency associated with it. Anybody can actually evoke this program by making call to this program, and then program will basically get modified based on those inputs and provide you output or money, something like that, based as defined in the program. And then the idea is that basically you will make such a system of programs, and it will be run by all the miners which are running on the Ethereum to generate maybe a universal distributed computer. That's a dream that Ethereum is trying to build, and there are very, very interesting programs that are already running on the Ethereum network. Another example that I should touch upon quickly is regarding the Hyperledger, okay? And the Hyperledger, the system is that it's an example where the industry started to put more efforts into the system. So it's initiated by IBM and Linux Foundation as an open source project, where what they want to do is that rather than creating one chain, they want to develop maybe I'll say open source tool sets, so that you can they will have different possibilities which are present. You can either code in this language, that language. You may have different kind of consensus algorithm that are possible. Typically, they are the first one who see that no, we want to have a sort of permission system. By permission system, I mean that in the earlier example, what we saw there, anybody can join the network, and basically anybody can become the decision-making part. So that's why we require proof of work of some kind. But it may happen that in the more organizational setting, we can predefine this set of participants. We say that these 10 players or these 9 players or these X number of players are the one who are going to run this whole consensus process or agreement process to stop double spending. And we trust them or we trust majority of them, or we trust 2/3 of them. And then we can basically employ the asynchronous broadcast protocol, PBFT. If there are some people from distributed system, they might be able to associate themselves with this term. So we can develop such systems. The advantage will be we don't need to do such more computationally expensive tasks, so it will be very fast. But obviously it's a permission system, because nobody can just join the system and become one of the guy who makes the decision. You have to be approved by others before you get added to the system. But maybe organizations and industrial setting, they find it interesting because it's much faster. So that's also something which Hyperledger developed one protocol. They also are developing something based on the Intel SGX scenarios, and even the standard open permissionless system also. So their hope is that they will just generate a big tools, like set of tools, and you will pick and choose from there to build your own blockchain for your own purpose. Okay, and IBM is certainly looking there to make money by working as a consultant, so that they can tell you what's the right thing and keep track of things actually work for you or not. Okay, so that's certainly something which is a big thing in industry. When I interact with some of the industry, they are typically looking into the Hyperledger as one solution for their internal processing. So that's like the basics for the Bitcoin that I wanted to cover. So before I start talking about the privacy issues in terms of the bad part of my presentation, any questions so far over here? Yeah.
So 2 questions. One is, can you give an example of the kind of things which think you can do with Ethereum, the kind of applications that might run on this.
Yeah.
And the other one is, you mentioned at first that that people want to use blockchains for anything these days. So what would you say characterizes the space of problems for which you would use a blockchain as opposed to some other tool? Exactly.
So both are related questions, both are excellent questions. So let me start with the first example. So there are interesting contracts on Ethereum. The one very nice and simple intuitive example can be like crowdfunding example. So crowdfunding is the idea that, let's say I have a nice idea, but I don't have money to just fund that project myself. Instead, what I rely on is that maybe I'll post the idea and I'll ask people that, hey, if you want to pay me, you can actually use this particular contract. Okay, I need this much money, but people may not have money to just pay me immediately or pay the whole. Okay, so it can happen that, let's say I want to I want to run a new venture. I need $1,000, and let's say you only have $100. So you don't want to just give that money to me. Instead, you want a contract in the system such that you will put that money in an escrow. Okay, such that if there are other 9 guys or other few guys who provide money to such systems, so that now we have $1,000 in place, then we can take this money and it will be available for me to use. But let's say you put a time block there that, okay, you give me like maybe a month to get other capitalists to put money on that. If I don't get that capitalist, you get that money back. And all these things happen without me doing anything, but we just use this the whole contract systems, and that takes care of such crowd source funding or crowdfunding scenario. So this just shows the one very interesting thing, that we define the rules and we encode these rules as a contract, and now things are taken care of. And I think even now, like, this is one of the most prominent example for that is employed on Ethereum.
So this relates to the second question. So why use something distributed, etc., for that, and not just your standard?
Yes. So now the second question that you ask is that what are the scenarios where indeed we should use blockchain? And as I mentioned, indeed that there are scenarios where people are just trying, but maybe they don't need it. I mean, if I'm a small organization, or maybe I'm a mid-scale organization where I already have a centralized system which is in place to keep track of how things move in my system, and I can just basically scale that if I need to make sure that the logs are not lost. But at the same time, there is no decision making that has to be made. Any transaction that comes, if signed by I have a proper system in place that people with the only correct credential can send me the transactions, and I can just collect them and keep such a ledger locally or in replicated fashion. In that case, I don't need blockchain, because there is one central system which can keep track of decision making, what to accept and what not to accept. Then why we need such a distributed consensus system? Instead, if I'm even still when I'm even a single organization, but I'm across different countries, or maybe we are small series of organizations who want to perform one task in a combined manner, such that no individual should be able to make or reverse the decisions. At the same time, I want to get the transparency, how the money flows or how the good flow from one organization to second organization and so on. In that case, indeed, it makes sense to consider blockchain, but not in the first case. Make sense? Okay, good.
Is it true that blockchains are used to register marriage?
Yeah, you can think of such a system, I guess.
I read about it. Two people got married and registered in the blockchain.
Maybe I haven't seen, but is there already an example like that, or?
I read about it, yes.
Okay.
How common it is. But what's good is there's no doublespending, so it prevents bigamy.
Yeah, I mean, it's an interesting thing, right? I guess because proving that you're married in one country and going in other country is difficult. I mean, I had to do that myself, so I know that it can be an interesting example. I was not aware of that, but sounds interesting.
You can get a divorce by generating a longer chain.
Yeah, or delay it at least, right? Interesting. Any other thing? All right. So then I'll move on to the bad part. My bad part is not big, but as bad is like clear, and it is a clear-minded problem. It's a simple problem. So we talked about that we are not using the true identities in such system. We say that instead there is pseudonymity, and that was one of the things that people like Bitcoin. They say that, hey, there is no identities of me which are present in such a system, which is an interesting thing, and that means people can't just keep track of me. And it was important because now we are generating such a, at least for Ethereum and Bitcoin, such open systems, anybody can download this big database and try to do all sort of crazy things on top of that. And they say that, okay, good that my name is not present over there. However, there is a still pseudonymity in the sense that your identities in terms of your public is still present over there. So maybe there can be some things which can happen with that. And in fact, it is certainly something which is a huge problem, because when I use that same pseudonym to actually withdraw, let's say, dollar for those Bitcoin, I have to go to this one exchange, and those exchange may require to keep track of that which real world identities or which real bank account or real name that is associated with this particular Bitcoin address when they actually perform this exchange. Okay, and even when I'm using lots of identities in the system, if they're all linked together, they're still pseudonymous, but they're linked together, then that's it. I perform one transaction with one identity, where my real identity in this identity or the address in the Bitcoin system is now linked. And if that address is linked to all of my other addresses in the Bitcoin system, then anybody can find out all the things that I have performed or all the money that I received in the Bitcoin system. Okay, so that's an inherent problem with pseudonymity, that if you have linkability, that can be exploited eventually, and that's just bound to happen. And that's what also the case in the Bitcoin, which I'll just try to show with this example that we looked into, right? So what we saw in the basic example that we had, that Alice has this 70 point some Bitcoin. She performed one small transaction with Bob and gave her that one Bitcoin to Bob, and rest all collected in her return address. Okay, to have better anonymity, she created a new address. I mean, creating address is cheap; you can just create them. And she created a new address and put all that money over there. But obviously anybody can see this transaction and make such huge linkage. They start, okay, this Alice identity, we know where, because this is the identity which got money from the exchange, which put some dollars, and now this is the address that we know belongs to this identity, this Alice. And we see the spending pattern here, where there's the small transactions that are going out and the bigger ones are getting collected into account. Okay, and now I know that, okay, most of the I can have a heuristic that all these accounts belong to the same identity or same person. Okay, that's just a one simple heuristic. When people also define heuristics, well, they say that you can add multiple accounts or you can add multiple inputs to a transaction. So that most of them, if you have multiple input to the transaction, probably they are coming from the same user's different account. So they also try to combine them together. And doing that, they were able to actually, this is from slightly old, this is things from 2014, 13 kind of things. So they were able to do very complex charts, and they were able to create all the accounts that belong to some identities, typically some big players or some of the parties who were allowing different services, and they were able to not only find out of their transaction volume or amount of money that is getting used on such system, but also which users are using such system. And there are just series of works starting. I mean, maybe there are few which I must be missing, and apologies for that. But there are just series of works which look into different systems, and in Bitcoin or outside, try to do analysis from the networking perspective, where you try to look at the linking between IP addresses and the addresses that are performing transaction, as well as the different transactions that are happening, looking at the transaction value, the patterns of the transactions, and you can basically form a complex graph where you will combine different identities belonging to an individual. And once any of these identities get assigned to their real identity, we have a privacy leakage. Okay, we'll see another example associated with that with the credit network also in my talk on Tuesday. But why is this a big problem? I mean, people, as I mentioned, people indeed joins or are interested or were interested in such a system because of nice privacy guarantees. And as find out by this Green Associate survey, they surveyed different people in market, mostly in the financial scenario, and they found that they value, 56% of them value the secrecy or the privacy aspect of the transaction confidentiality is certainly a major concern for them. And it's not so easy to see that there are also already regulations which are in place. Certainly EU is the forerunner in the data privacy regulations. There can be also some contract level details which works at the industry level or in between the organization, and they want to make sure that there is a privacy which is protected over there. Okay, so competing organization may not like the other competing organization know about their transactions, or I as an individual may want to make sure that I'm using this particular pharmacy, or I'm using this particular doctor or a particular service. I want to make sure that that is not available and can't be found out by others effectively and immediately. So there are certainly privacy issues, and indeed it's a big deal. Okay, so. With that, we know that the thing is clear. Yeah.
So if I manage to de-anonymize you in the sense that I realize that all these transactions are associated with these public keys, what's my next step? That is, how easy is it for me to understand that you as a person are behind these public keys?
Yes. So the question is regarding actually once we are able to link different identities, how can we take those information and link that to an individual? So the idea is that some of those identities or some of these addresses, or even one is sufficient, may eventually get linked to my real identity via the transaction at exchanges. Or maybe sometime you just publish there are forums, for the Bitcoin forums, or some people also do use Twitter, where you publish that, hey, this public key belongs to me. And maybe people may say that, okay, that's good, because I know that this public key I'm only going to use for the transaction where I don't want privacy. But maybe you make that one mistake where you link that to some identity which you want to keep the privacy, and now you are able to basically find it out. So you first perform the linkability, and then you basically add on top of that de-anonymization, which allows you to go much further. Yes?
Or you buy something physical and it is sent to your home, and then the seller knows that this key belongs to your home.
Yeah. That way you can find out the address as well. That's correct.
It turns out that drug sellers give the addresses of the neighbors or the other guys to prevent that. So if you get...
Yeah.
But if anonymity is very important, you can just buy Bitcoin with cash. You go to someone that has Bitcoin, you give him cash, and he sends you Bitcoin, and then there's no link to your identity.
When you convert it back to cash, right? You do it somewhere, so that at least.
Yeah.
Yeah.
And also that person now becomes somebody who you trust, right? He knows what Bitcoin are given to you.
Yeah. Only this person.
Yeah. The question is just finding out there. Obviously it's not completely broken, but the idea is that more linking you perform, I guess at least in the privacy community, we see that once you have linkability, eventually something or other can get broken. Even I said, we talk about this drug person, it's a Silk Road guy, he was using Bitcoin, but eventually, I think his fall was not completely because of Bitcoin, but that also played a role where they were able to identify his one real, some pseudonym which was well known, and they're able to associate that with his some other pseudonym which was not so well known through such transaction, and that leads to his.
Yeah. Maybe you would mention that there are solutions to
Yes. So that's what I'm going to now. That's a third part of my discussion. That's the ugly part. There are solutions. It's not a perfect world, but we are making good progress. So what I'll try to do is that propose some approaches, as well as talk about the issues that are present there and interesting problems that we can solve in this space. So I'll try to give a brief introduction to all this system. Okay, so I'll say that the key approaches for the blockchain privacy, and I'll say it's a zoo, in the sense that there are interesting small nuggets, small crypto tools that are present. Not everything is not so small. There are some big projects also there, or big tools. And basically not everything works with all blockchains. Some things work with Bitcoin, something works with Monero, something works with Zerocoin, Ethereum, stuff like that. And the idea is that when you want to use a system, you just combine the topics that are relevant and works in that system and try to get get better privacy. Okay, so what I'll try to do is that try to give some brief informal description for all these prominent PHI tools that we look into there that are typically employed in for the privacy so far, and then I'll talk about what still goes wrong and why when some people claim that there's a really good privacy and which is not. Okay, because some of them are very interesting and very strong tools on their own. So I'll start with the basic solution, which is peer-to-peer mixing, or in Bitcoin system, I'll associate that with the coin join. So coin join in Bitcoin system is that, as we saw, there can be multiple inputs that you can put in one transaction. Okay, there will be multiple transactions which are present and we add them input. And let's say typical scenario it is that you are combining several of your own transactions and you want to pay using multiple of your transactions, but why can't we make sure that it's coming from multiple users? Okay, so here I'm showing there's Alice, Bob and Carol, and all they are putting one Bitcoin. Okay, and we simultaneously can also have multiple outputs. So here I'm showing they are talking about 3 different addresses maybe belonging to them or their receivers. Okay, and important thing is if I make sure that these values are same, or at least the transaction values are same, then the order does not matter. Okay, and the idea will be each of them will make sure to say that, hey, is my output present on the second part? And if that is the case, that yeah, I want to actually transfer 1 Bitcoin from A to A prime, and A prime is not easily linkable to A, then Alice will just sign it, and so will be Bob and Carol. And this concept is called as coin join. Okay, which is allowed by several. It's basically it's also called as multi-sig because you include multiple signatures to achieve this concept. Okay, but the question is that how you actually get such addresses added there. That if Alice, Bob and Carol trust each other, then they can do it because they'll just form basically a TLS channel or something like that to communicate with each other, and then they'll just create such a link and publish that and make such a transaction. But assuming that is difficult, I mean, you may easily get tricked because somebody may just join as a passive listener. They'll perform transaction with you, and but they can still keep track who is sending what money. Okay, so the problem that we need to solve in this space is known as anonymous broadcast. What I mean by that is that I'm going to assume 3 players, Alice, Bob and Carol. Okay, but you can have any such number. They will have their own output addresses, like A prime, B prime and C prime, which will be not known to anybody but them. Okay, and you want to make sure that they basically send this on a bulletin board, such that eventually on that bulletin board we are going to have a listing which is some permutation, some random permutation of the input that is provided by them. Okay, so it's like a broadcast, but with the anonymity property that people will see that there are 3 addresses, there are 3 input providers A, B and C, and I didn't show the protocol in here, but then the magic happens and eventually on the bulletin board we see respective output addresses, but we don't know which address belong to which of the initial provider or initial user. Okay, how
They have to know about each other, or they have to cooperate.
Yes. So there are different approaches to that, and I mean, I decided to not include math side, right? But basically, they have to coordinate with each other. They have to communicate with each other in several. That's why I'm using word P2P mixing, but that's not necessary. It may happen that they actually use a single slightly trusted system or a hardware or something like that to let that hardware take care of that. Okay. But for simplicity, I'm going to assume that it's the example that I'm considering here is basically a P2P mixing scenario. Okay. So let's try to see first what we achieved through such system. What kind of privacy we achieve. One thing we can easily see here is that we call this as relationship anonymity in the anonymity literature, where the property that we achieve is that we know that these are the set of inputs or set of senders. We know that these are the set of receivers, but we don't know which sender is associated with which receiver. Okay, so it's a It's not only sender or receiver. We can define the anonymity also in terms of the anonymity to the sender or the receiver, but here I'm just converting that to the relationship anonymity because it's a correct property that is achieved through such anonymous broadcast. Okay, but as you can see, they all are performing transaction for the same amount, right? I mean, if the amounts are different, then somebody can just look at the different amount values and just make the linkage between the appropriate sender and the receiver ID. So we want to keep the value same, and that means that there is no value privacy whatsoever. We know that Alice and Bob and all these players perform transaction for exactly this amount. Okay. Coordination and communication is necessary for this to happen. First, they have to decide that, hey, who all want to perform transaction for $1? And everybody says that, yeah, I want. And basically, they make such listing and then say that, okay, all these players come together and then they try to mix their systems. So it's such a coordination and then basically a protocol that you have to develop to perform this anonymous broadcast is necessary in this case. Okay, but it is compatible with Bitcoin. I mean, it works with current Bitcoin system once we get this anonymous broadcast done outside the system. So Bitcoin part is only that. Bitcoin system doesn't take care because once there is a system which is available which allows you to create such a listing of A prime, B prime and C prime in a permuted order, that's it. You can take that output, include it here, and now everybody can see that, yeah, I see my output there, and they can respectively sign and perform the signature and allows them to actually mix their system. So once we take care of the anonymous broadcast part, the coin join takes care of the anonymity or the mixing part in the Bitcoin system.
And the coordinate, but still A does not know about B, about what we said.
Yeah, so what property we want here is that A knows that, yeah, I see A prime, but A doesn't know for the rest to address when it sees B prime and C prime, it doesn't know which of them belongs to B and which of them belong to C.
And the others don't know anything. The others outside the group don't know.
Yeah, so people outside doesn't know. In fact, we can quantify this property precisely saying that as long as you have two honest parties or two honest users, they can mix with each other. Rest of the things can belong to it. Okay. We obviously can't go below 2 because anonymity required company. You have to have somebody else to anonymize with. Okay? Yeah. Thanks for the question. So the two examples that I'm showing here, these are the two things that we developed in terms of CoinShuffle and CoinShuffle++. I'll be happy to. They use very interesting mechanisms, and at least in the CoinShuffle++, which was the NDSS paper this year, we are able to perform this whole process in just 3 or 4 rounds. Depend upon in the optimistic or pessimistic scenario. So we're able to perform this much faster, and that's what we the key achievement that we had, and it works for any number of parties. As long as you have 2 honest parties in your system, your protocol will complete. Okay. Moving on, another thing that we can perform is that if you want to perform mixing, but we don't need to have this coin join, right? Instead, let's say we have a single mix system in between. We can employ them also in such a manner so that all people will send their input to the system, and they will tell this input, hey, take this one Bitcoin and convert that Bitcoin or send this Bitcoin to some other party. Okay? And at any given point of time, if you have enough messages which are present in this particular mix system, then you have that much amount of anonymity so that people can't know which of the input went to which output. Okay, as you can see here, it's an interesting approach, and there are different solution with different space which are present. I mean, one thing that we can always ask is that, hey, hang on, now this part in between knows who are the senders and who is the receiver, right? They can break the anonymity. So in the first paper which came, I mean, one of the first privacy enhancing technology that got developed for Bitcoin, the Mixcoin paper, they show that, okay, yeah, this guy will know this information, but he'll be accountable. He can't steal money at least. So we make sure that he can't steal your money. Okay, so we started with that. But then there have been series of works, and eventually went to Tumblebit, which also appear in NDSS along with our paper, where they are able to show that this guy in between has no idea who is sending to whom. He just is completely, if he doesn't perform his task, then he is the one who is going to lose money. Okay, and you make sure that you get anonymity, as well as you don't need to have any trust assumption on this party, except for point of failure. He may go down and obviously lose money, but you also at the same time you also lose your ability to perform mixing or ability to mix your coins.
Is communication with this mixer direct, or is it broadcast and everything?
Again, I know that you're coming to the question. So generally, I'll say, I wanted to come to that slightly later, but indeed, several times in when we talk about these protocols, this is certainly something which goes under the carpet. It's like, yeah, happens. And if you go in more detail, the answer may just come up to that, yeah, just why we'll do that over Tor. But maybe we'll come to that problem very soon. And indeed, it's a very important thing that once we start using this system in practice, we have to take care of that. Okay, yeah, excellent question. Yes, so this basically in this such single mixing scenario, let's say Tumblebit, in this case, we have better relationship anonymity, because now my anonymity depends upon the number of inputs that are present in the mix, which are not yet sent out, and my input can belong to any of them, and that's the reason it's as long as if you have a reasonable size of transaction which are already present in the mix, that provides you a reasonable chunk, which is with which you can perform the mixing with. Okay, but obviously the interesting thing here is that there is no coordination required on ADC. Yeah. You want to ask? Okay.
I was wondering, is that a limiting assumption? Can you generate fake identities and add enough noise to the system so that
you can do that, but then the question will be, we don't want to make any assumption on this mix node in between, right? So he may try to do that, but that's not provide anonymity against him. That doesn't provide anonymity against him. And at the same time, we do not want any coordination. So that's why I added exclamation mark over here, and sorry, question mark with the exclamation mark, that although it provides better privacy, but you have to make sure that there are enough people who are present over there. In the P2P mixing, we know that these guys will take part in the system. But here, you rely on that there will be enough people, or he's going to make some kind of a condition that I'm only going to perform mixing only when there are enough people who are present over there. Okay.
What about the value? It says it's in different values.
Yeah, but again, the value has to be same, because people can see the transaction when that gets settled. So the value privacy you don't achieve in this approach.
So you can see the incoming value.
Yeah, but then that's why all these the mix we're going to publish saying that, hey, I perform mixing for 1 Bitcoin. And then you only contact him if you want to mix 1 Bitcoin. You don't contact them if you want to mix 2 Bitcoin. Then there'll be other mix who does that job. So you have to define that on the value basis. Okay? Yeah, we'll try to solve that problem in some systems in coming slides very soon. Okay, so indeed, I guess there is because it achieves the better properties, and obviously because having one central party, it has less coordination and communication. There's already some people who are working on the implementation for the Tumblebit, which may get used for the Bitcoin in some systems soon. At least there'll be some clients which will satisfy that. Okay, but that's just two things. That we can also do something other interesting things. The prominent example of that can be ring signatures. Okay, so ring signature is a very interesting thing. I guess you don't again need to understand any crypto, but it's a cool tool that all people should study. It's a very interesting tool to be used. Okay, so what ring signature is that? Typically in the signature, I know the message. I use my signing key and I sign the message so that people can now verify that yeah, this message is signed by Aniket, because this public key belongs to Aniket. Okay, but in ring signature, what you do is that you also pick some random public keys which are present for 10 different guys or some number of guys which are nearby or with which you like to actually mix yourself with. Okay, and you will create a signature so that people know that Aniket and either somebody, one of Aniket and these 10 guys have signed this message, but we don't know who. Okay, so actually you create a signature for any group possible without revealing which member actually created the message. And it's a very interesting nice privacy tool. You don't need to talk to them, guys. You just have to know their public keys. You take those public keys, you take your signing key, and you generate the signature. Okay, but obviously you should start thinking that hey, double spending will be a problem here, right? Because then I can just try to mix with people and spend my money twice. Basically, let's say take the same coin and sign it twice. So that's why the word traceable comes in picture, that where people come up with a construction where in several scenarios it can indeed happen that we want to make sure that although you have privacy, but you should not sign twice. Okay, and the idea there will be if you try to sign or if you try to spend the coin twice, then your identity will get revealed. So people will know that, hey, this is the identity, and then they know that, okay, then we should not add both to transaction system because the identity gets revealed, and they also know that there is a double spending that's happening. Okay, so the traceable ring signature provides an interesting aspect to here. If you look at these properties here, it's slightly different. It's a sender anonymity. It has nothing to do with the receiver address. Just like I, as a sender, add different address to my system, I see that one of these parties have signed this message. Okay. Again, there is no value privacy. Currently, we are not touching the amount part at all. Okay. No coordination required. Very important. There is no coordination whatsoever. We just pick some of the public keys which are present and use that. It increases the transaction size because at least for the most of the constructions that are present currently, the size of the signature grows linearly with my anonymity set. So more public keys I add, my signature increase. People are working to solve this problem, but at least this stays as it is now. It's not compatible with Bitcoin because this ring signature has to be added. But there is a newer currency called Monero that come in picture, which decide that no, we are going to use it, and basically it's possible, and they are already using a ring signature based system over here. Okay. The thing with Monero, however, is that it's a difficult anonymity among other properties because in other systems, the other example that we saw with the Mixcoin and others, we know that the other input providers are also taking part and they want to achieve anonymity. Here, the other public keys that I use may not be interested in anonymity. And let's say for simplicity, I took an example me as identity A and some identity B or some other public key B. I added those two public keys in my ring signature. And in second transaction, that public key B provider just perform a standard transaction with somebody without adding any ring signature. Okay. Now that means anybody who sees those two transactions know that, oh, that guy actually is not the one who is the sender in this current state because he used that, he actually performed another transaction which was not privacy preserving to spend the money. So it's possible to actually easily break the anonymity in this case, and there are two papers which we recently come up which try to attack this Monero system based on exactly these properties, that how those public keys are chosen and how badly those public keys are chosen, that things, although it looks good anonymity, is actually that's not the case. Okay. Another very interesting property is the stealth address. Now we are shifting from the sender anonymity to the receiver anonymity. Okay, so one thing we can try to do is that whenever anybody want to send a transaction to me, I can tell them that, okay, I create a new public and private key pair and tell them that, hey, send transaction to this particular account. Okay, it's an interesting aspect, but still it's coordination and there are some efforts that one has to put, and there are several things that can go wrong in such a system because once you eventually started to spend this money, again things can go wrong for you. But what stealth address tries to do is that solve this problem such that now this onus of creating new address is not on the receiver but on the sender. Okay, so what I mean by that can be clear from this very interesting simple figure. So let's say I as a receiver has a known public key that we know that somebody want to send Aniket money on this particular Bitcoin address. Okay, so my public key is known. What we can do then is that a sender, let's say some Z, he can take this public key, he will create another ephemeral key, a temporary key, public and private key pair, and use my public key and ephemeral public and private key pair to generate a stealth address, okay, a new address, and send money to this address, okay, this public key. But this stealth address is a very interesting property. Only I, the receiver, can find out the private key. Not even the sender who sent the money can find out the private key. Okay, so it adds a very interesting thing that the sender is sending money, it generates the public key, but it can't compute the private key for that, because it has to follow a certain procedure that you can keep track of. Okay, important thing is I can find out that private key. Nobody, again, based on the standard cryptography assumption, nobody can take that stealth address and my Aniket, the receiver's original public key, and find link between them that, hey, this stealth address belongs to this particular public key. Okay, it's not possible. But I, knowing my private key, can find out that, hey, this address belongs to me, so somebody send me money on this particular address. Okay. Any question here? I know, because I know that it's an interesting but slightly complex concept.
The sender can still compromise my identity?
The sender can still, sender knows your identity, yes. Sender knows your identity, but sender can't know the private key. But
can he prove my identity to others?
Can he prove your identity? That's a very good question. I have to look into, there are a couple of construction, but we have to look into details to know that exactly. But that's a very interesting thought. That has to be looked into. But the hope is that he wants to send money to me, so he already knows my identity. But maybe you are talking about that, can he go later in the future, say that, look, I send money over there. I'm not sure. I think it will be interesting to check that. Yeah. You were also asked.
So could you confirm the payment if the receiver denies receiving the payment?
Yeah. So the receiver. So the question is that, can you confirm the payment? And the receiver. Here is what receiver has to do. He knows his private key, and there will be some ephemeral key and stealth address which are present in the transaction. He has to go all the transaction that has happened, see that, is that transaction for me? Is that transaction for me? And eventually he'll come across a transaction which is for him, and then he'll know that, oh, I got the money. And the cryptography makes sure that he knows nobody else can spend this money, and I can only spend this money.
But if he denies receiving it, then the payer won't know that he actually did receive it.
But what kind of deniability you are talking about here, right? Because I can always, you can send me money and I can just say, oh, I didn't get it. So.
But if it's a public ledger, then you can confirm it.
Okay, so you mean, okay, I see. So you are saying that anybody can confirm that, anybody who knows my public key know that I indeed receive money from you. And here you are saying that, is it possible to prove that actually? I think that question is quite related to what he's asked. So it's a very interesting, I don't think it's taken care of, but I might be wrong. So I'll certainly check that out, but that's a very interesting thing.
This is a problem that's general without privacy. If you pay to my private address and I deny that's my private address,
yeah.
The recipient can always deceive the sender.
Yeah, but that's what I think you are assuming that, let's say if receiver's public key is indeed, let's say receiver is a well-known entity whose public key is well-known, then it's possible to show that indeed I paid them at that point. Yeah, no, that's a very interesting thought. It's not extremely complex crypto protocol, but it's an interesting protocol, so it can be checked out very quickly. But I just don't know the answer at this point of time. Interesting question. Anything else?
I just want to understand the privacy property.
Yeah.
Is this different than how it's different than? Okay.
Yeah. So the privacy properties, now we are talking about recipient privacy. Okay, so that sender knows the recipient, but others can't determine who is the recipient.
So this is kind of equivalent to generating a different public-private key pair for each transaction.
Yeah.
Is that the goal?
Yeah, that seems. But with the caveat that indeed now is the sender who creates this for you. You don't need to. The receiver doesn't have to be online and do all these things and tell you. Sender just do that, and receiver in the future determines, oh, this transaction belongs to me, and downloads it. Yeah. Okay, but again, we haven't yet touched the value privacy. I know that I probably shouldn't, but we'll soon come to that as well. Okay, no coordination required, but recipient has to continuously watch afterwards that, hey, which transaction belongs to me, kind of thing. Okay, there are delegation scenarios where people say that, oh, I'll give you some part of the key and then you can determine if that transaction belongs to me. But at the same time, you will only know that this transaction belongs to this user, but nothing beyond that. So there are some interesting delegation scenarios which are possible. But again, they are not perfect. There are things that can go wrong in that case. So there is a possibility to get it done. It's already employed. I mean, all really strong protocol, like good privacy protocol like Monero and Zcash have using stealth addresses in their system, and it can be retrofitted in Bitcoin. But the thing in Bitcoin will be that people can see that, hey, here stealth address is used. And the reason for that is in the standard Bitcoin, the output key or the receiver key is basically a recipient's public key, which is just one value. But here it is a pair. Okay, it has to be an ephemeral key and a stealth key. Both of them has to be present there. So anybody can just see the transaction that this is the stealth address and this is non-stealth address. So it can be eventually used to again de-anonymize or break a system. So although it's retrofitted in Bitcoin, it does not add too much value privacy unless everybody starts to use it. Okay, in these other two scenarios, it's must and it has to be used. Okay, now finally we start looking into what can we do for the value privacy, because we have been just trying to avoid that for a long time now. Okay, there we have what is known as confidential transaction, where we say that why shall we keep the value in plain? Why can't you use the concept of cryptographic commitment so that you will take this value and you'll commit to it rather than keeping the value? And I'll commit to this value. It's the idea to cryptographic commitment. You take this value and commit to it so that later you can open to a particular party that, look, this is what I committed to. And it's binding in the sense that you cannot cheat in future. Okay? And at the same time, it's hiding that unless the initial committer decides to open it to somebody or to public, people have no idea what the value which is committed to. Okay? So the way to use cryptographic commitment is that the sender is going to commit to the value, okay, and he will only going to tell receiver that, hey, possibly in private channel, again we are not looking into the network aspect, but hey, this is the message that I've committed to, and this is the randomness that one has to add to it. Okay, and receiver that, yeah, makes sense, and then he'll approve it, but rest of the world has no idea. Okay, but we have to do the bookkeeping correctly, right? It should not be possible that I put 1 Bitcoin inside and generate 10 Bitcoin outside. Okay, so that tell receiver that, hey, I've committed to, I should be able to only spend the money that I have and not money out of blue. Okay, and that's where we add a range zero knowledge proof, where what we do is that we prove that value rise in a particular range or a particular value. Here, what we need to make sure that the input and output sum to 0. Okay, you show that, okay, this is my input, this is my output, and when you actually take the input and output, and if because of the homomorphic property of commitment, you get finally commitment to the value 0, and you just say that, okay, this is indeed, this one value is the commitment to value 0, that's why I have the property that I want. Okay, so this way we get value privacy. Okay, but here we're not talking about any sender or recipient or relationship anonymity. But still a very interesting concept. It increases the transaction size because commitments are slightly bigger than the standard things, but the change is not huge. Okay. Also, there is a transaction size increase because we need to add the zero knowledge proof or the range proof that we have to add. But the interesting thing that we can perform is that in Monero, for example, they added ring signature, which is basically sender anonymity, stealth addresses, which is receiver anonymity, and commitment, and they combine them together to get sender anonymity, receiver anonymity, and the value privacy, to add all of them together. Okay, in value shuffle, which is work done by my 2 students, they had a Bitcoin paper on that, in Bitcoin workshop. They add these commitments or the confidential transactions and CoinShuffle++, which was a mixing protocol, and now we can protect both the relationship anonymity and the value privacy. Okay. And once the confidential transaction works on Bitcoin and any such system, it will work in the scenario. Okay, but we haven't yet looked into the biggest solution in that space, and that is the Zcash, which is already a system that is been employed. What they do is that rather than relying on a tailored zero knowledge proof for this value, they use what is known as the zero knowledge succinct non-interactive arguments of knowledge. And the key word here is the succinct. So the question is, you want to make those proofs that correct input and correct outputs go in the system as small as possible and very fast, efficient to verify. Okay, and they employ the stealth address and such a proof. I'm not going into the crypto details of that proof here. And they employ these 2 techniques to get the very good properties in terms of the verifiability that things are happening in correct manner, and the transaction size, everything remains much smaller as compared to the existing techniques. Okay, so there is a sender, there are all the value privacy as well as all the anonymity properties which are present. In fact, the anonymity set, because of the way the zero knowledge is defined, is that for all the transactions. So anything that is put into the mix or to the system sometime may be associated with what comes out. So that's a very strong anonymity property. But there is a trusted setup that is required, which some people in the community don't like. So there is already a Zcash currency which is present and is employed by few people, but it's not one of the most prominent pair as of now, at least. Okay.
Trusting to generate correct, what's the trust assumption?
So there is a setup that has to be computed either by a trusted entity or in a distributed manner. And again, it can't be like a P2P system. It will be like they'll say, oh, these 10 guys perform this setup, and as long as half of them are trustworthy or honest, or 2/3 of them are honest, then this is a correct assumption. But that's only setup. Once the setup is done, then things remain independent of their trust on them. Okay. So again, then I'll come to the interesting aspect that in all these scenarios, we never talked about things can go wrong at the networking level itself. Okay, and that's what I'll probably have to use. I think, how are we doing with the time? I guess.
5 more minutes.
Okay. So I'll try to cover at least the basics of that. I won't be able to cover the more of the details, but I'll at least give 2 examples as something which can be very interesting. Okay, obviously in all these different scenarios we can define interesting networking scenario, but let me take 2 examples to just consider the attacks that are possible. Okay, and I'll just take one as the announcing transaction and second fetching transaction. Okay, so when you are announcing the transaction on such a system, it's a peer-to-peer system if you have Bitcoin, or there are some miners or validators which are present to whom you have to send your transaction. Okay, these guys can easily see that this particular public key or address belongs to this particular user. Okay, so we are inherently relying on they are not doing this linking, and we can't solve this problem just purely cryptographically. Okay, so it's a very interesting problem which is not addressed by this existing scenario. Okay, another thing that we need to perform is that as already the question came, that sizes of these blockchains are going to increase. I mean, for Bitcoin it's easily more than 150 gigabyte. I think that's number correct. On the slides I use 100 gigabyte just to be on the sure side, but the transactions, they're huge. So you don't expect my mobile client or even my laptop to download all this information. Okay, instead what people started to do is that there'll be thin clients which will contact a few full nodes or few nodes, and as long as one of them is honest or one of them is correct, they know that they got correct information. Okay, it's certainly weaker assumption, but many times it's a sufficient assumption. Okay, you can combine that with the previous knowledge you have for the system and stuff like that to also make it very difficult for those guys to cheat you and provide you wrong information. Okay, they can still provide you stale information. So that's another aspect. But now here, the information that you download will be typically for your own addresses. You want to determine that somebody send me the money, and I want to make sure that I get that, I got that money. So I'm going to check that, hey, can you please tell me how much is the money that is present on this particular account? And now this guy, this full client will know that, this address belongs to this particular thin client person. Okay, and there are already attacks which has happened where based on this information that you know that this particular IP address has this much or these big lot of Bitcoin, people have launched the other networks attacks on those systems to obtain their private key and get their money. And for them the thing is simple. They will not go after anybody. They look at the people who have a lot of money and go after them because those are the lucrative targets. Okay, so indeed we need to make sure that this announcing the transaction and the fetching transaction aspects are also taken care with some privacy. Okay, so obviously, I mean, I'm not the first one to think about this problem, and people will just say, hey, why don't we just do this over Tor? Okay, so I assume people know Tor, but for those who don't know, it's a system to basically perform web browsing or instant messaging or tasks such that in an anonymous manner, so that you can actually retrieve information in a manner so that people can't immediately find out what is your IP address, and it's hidden behind a series of proxies in between. Okay, it's a very crude description, but that's what again I can do in 1 minute. Okay, and but actually just associate this task that the Tor is defined for web browsing and instant messaging, and because of that it has a low latency and low bandwidth design. It is defined so that your message reaches and come back very fast, and it has low latency or it has low bandwidth, that you should not ask for too much bandwidth from your behalf as well as on other nodes which are on behalf. Okay, so it can only perform provide a weak form of privacy, in the sense that there have been already attacks that are shown for a determined adversary, a state-led adversary can de-anonymize some Tor traffic they have to. Okay, they cannot be always successful, but they can be successful in some scenario, and it has been demonstrated just by some experiment done for some example. I mean, you can easily find out examples of that kind. Yes, so the second point I'm coming here is that I mean, this has been changed slightly, but there was the concept that if you make illegitimate requests from some IP address, then Bitcoin nodes basically block that IP address for some time.
What do you mean?
So that I'll not get those requests from, I'll just, so whenever I get a fetch request or I broadcast request for the transaction from that IP address, and if that verifies to garbage, I'm not going to accept information from them for 15 minutes or 1 hour or something like that. Okay, but now what can I do is that I can basically take all the exit nodes, all the final nodes that are employed on Tor, send random transaction through them so that all of them get blocked. Okay, and except for my own exit node which I run. So if a user is trying to now connect to the Tor, they have to get connected through my node, my exit node. So they actually demonstrated that such attacks, and you can then combine such attack with different things to actually, in fact, when people use Tor to announce their transaction in an anonymous manner, they are actually more vulnerable than just sending transaction as it is. Okay, they try to fix that problem in Bitcoin to some extent, but it's still it's a problem that is beyond fix. Okay, also. Tor is frequently censored in many regions, and we are going to hear about the anti-censorship more on Tuesday, right? But the idea is that it's a difficult task and it's a huge problem in general, and Tor typically get blocked for different reasons, and all of a sudden now immediately it has a bad effect on all users. Okay, so even when I don't plan to use Tor for that purpose, I can't send my transaction in a privacy-preserving manner. Okay, and anti-censorship is a difficult problem, and the techniques are far from being perfect. Okay, so it's a very difficult task that you can overcome this problem, right? And several users may be hesitating, say that okay, whatever, I'll just give up on my privacy, although I only want privacy for Tor transaction, but if my government don't like it, I'm not going to use it. Okay, so that's again one more issue with just using or just do it over Tor issue. Okay, so members of the industry also hesitate to use Tor because it's typically associated with some activities, although they are not the most prominent activities, but they are associated, so they just hesitate that hey, our users should not use Tor. Is an attitude at least which is present in some industry. Okay, so that's why this assuming that one size fits for all approach of just using Tor to solve all the network level privacy problem is not very well suited when we look at the blockchain research, and that's what I think that there is an interesting opportunity that we need to look into and consider. Okay, but I mean, although we say the anonymity loves company, that means more traffic you have, it's better. It's not always the case, and when you mix the Bitcoin traffic with instant messaging traffic, that may not always give you the best of them, because such traffic can be easily fingerprinting and find out that hey, your message to YouTube and your message to Facebook will the fingerprint of those messages look quite different. So this is known as typically traffic fingerprinting, and it's well known that it's very difficult to avoid traffic fingerprinting. Your ISPs can very easily perform such attacks. Okay, so I know that I'm coming to the end, so I'll probably just then stop here, say that these are interesting things that we have to solve. Okay, and I'll just stop here, but we can certainly discuss more on this in our discussion. Thanks for very nice questions.
Thank you very much.
Yeah.